Okay, so we are looking at factorising using special products. The special products that we're going to look at are difference of two squares rule and the perfect square rule. So let's start with the perfect square rule, which we have already briefly looked at. So remember that when we were looking at it, when we were looking at for expanding, we were looking at a plus b all squared is equal to a squared plus 2ab plus b squared. And that basically just means that whenever I have something like this times by itself, so a second bracket there, then I'm always going to get the first term squared times plus 2 times the combination of a times b plus the last term squared. So that means that also with factorising I can go the other way. I can just, if I'm ever given something that looks like this, I'm going to go straight back and know that it's going into this bracket. So let's do an example. What if I've got x squared plus 12x plus 36. Okay, so in order for me to figure out what a and b are, I've got to look back at this. Look at this. What was the expansion? Okay, what was a and what was b? Now, for me to figure out whether or not this is going to be a perfect square, I have to go, well, for it to be a perfect square, I have to square root this, times it by 2, times it by this, and do I get this as my answer? So the square root of 36 was 6. 6 times 2 is 12. And then 12 times x, so yep, I have a perfect square in the form of a plus b all squared. So I can just factorise it back over to this, because I know that a equals x, and just make it a bit neater. A equals x in this instance, and b equals 6. So that means that when I go straight back over to here, I'll have x plus 6 all squared. How am I going to check if this is correct? Well, if I wanted to check if it was correct, I would just expand it. So this is the same as x plus 6 times by another x plus 6. Does it give me that? So x by x would give me x squared, and then x by 6 would give me 6x, that's half of that, that's fine. 6 by x would give me another half of this, and 6 by 6 would give me 36. So that's exactly what I'm looking for, perfect. I know that I've done it. So whenever you come up with a question like this, if it looks like this, 3 terms added together, in order for you to figure out whether or not it is a perfect square, just check by square rooting this and seeing if this is 2 lots of this times the square root of this. Square root these two, and if this is 2 lots of those, then you know that it's perfect square. It won't always be in the form of a plus b. You might have a minus b all squared, which of course the only difference is that I have a squared instead of a plus in the middle for my, what would be my x coefficient in the middle, I'd have minus 2ab plus, of course, b squared. And that's because negative b times negative b is going to give me a positive b squared anyway. So, if I've got x squared plus, sorry, not plus, we're going for minus. Minus 18x plus 81. Well, I can figure out what my a and b are in terms of what I've got right here, because I know that this, the square root of this is 9. If this is 2 times 9, this number here, well, x is obviously the square root of x is x, so that's the a bit. If this is 2 times 9, which it is, then I know that I have a perfect square, regardless of whether this is minus or plus. This will only change the sign that I have in the middle up here. So that means that when I factorise it over, I'm going to end up with x minus 9 squared. And I'm done. Remember that we're looking for going from this form to this form, we're going from, what is this form on this side? This form is all expanded. This is factorised. I want factorised form. Okay? Okay, difference of two squares rule, our second special product. So, we know that A plus B, when I times it with A minus B, I'm going to get my difference of two squares. So, A squared minus B squared. And the reason that happens is because when I do A by A, that gives me my A squared. And when I do B times minus B, well, that's going to give me my minus B squared. What happened to the middle term in the middle? Well, B times A and A times minus B are just going to cancel out. So, therefore, this is going to be my result. It makes it, when I'm going for factorising, a lot easier to identify, because all I'm looking for is two squared numbers, right? This is a squared number, this is a squared number. If there's a difference, a subtract in the middle, then I'm fine. The only thing you need to be aware of is it might not just be a single number in there. You might have a bracket here with a squared, or you might have a surd. And we'll do some examples to explore that. So let's just do one where we're having a look at two squares. So for example, what if I've got x squared minus 81? Well, of course, I want to go this way again. We are factorising. So I just got to look at, well, A in this instance was x, and B is the square root of 81, which is 9. Forget about the minus for now. And then when I put it in the bracket, I'm going to have x, that's going to be my first term. I'm going to have a plus and a minus, and then 9 is what's left. I find it quite a lot easier if you just put in, well, what was my A for both? Put the A's in first. You know there's got to be a plus and a minus. If the plus is over here and the minus is over here, it makes no difference as long as you've got A plus and A minus. And then you've got your 9, or whatever your other variable is, which is the square root of your B squared, yeah? Unless it gives it to you as x squared minus y squared, and then you know that you're just dealing with y. The only time you're going to have to square root it is if you've got the number already squared. Okay, so let's check out some examples. First one, A squared minus 5. Okay, so I know I have to deal with a special product. I'm looking for, which one is it? So first one I'm looking for here is obviously dots, because I've got two numbers there. This one is squared. What number squared gives me the square root of 5? Gives me 5. Well, obviously the square root of 5. Remember that if I've got the square root of 5 and I times it by the square root of 5, that's the same as the square root of 25, which is 5, right? So anything when I square root it and then times it by the square root of itself, it's just going to give me the itself. We can write that a bit nicer. We could write that using x. So if I had the square root of any number times the square root of any number, it's going to give me just x on its own. Because remember that whenever I have a square root, that's the same as x to the power of 1/2 times x to the power of 1/2, which is just x to the power of 1. Yeah? So, if that's the case, then I know that this is actually equals a squared minus the square root of 5 squared. Okay, and then I've looked at it and I go, well, now I've got two squares. I've got a equal to a in this instance and b equal to square root of 5. So when I actually factorise it, I'll have a, put my a in first, a plus and minus the square root of 5, right? Finished. Let's have a look at another example. 8d squared minus 2m squared. Okay, what do we always do when we're factorising? It doesn't matter how we're factorising, but we always do something first. Well, of course, we take out the highest common factor. The highest common factor here is going to be 8, coming out from 8 and 2, because obviously the d and the m, well, there's no factor there. So 2 goes into 2m, 2 goes into 8. So I'm going to take 2 out. So I've got 2 lots of 4d squared minus m squared. That helps me because now I can see that there's a nice squared number. This number here is going to be a squared number, whereas 8, well, that wasn't a squared number. It was going to make it a bit tricky for me. But now I know that 4 is a squared number. What is it the square of? It's the square of 2. So if I actually want to simplify that one a bit further, I've got 2. This is 2d squared minus m squared. Now I can see that my first term is going to be 2d and my second term in each bracket is going to be m, and then I can write it out nicely. So that's equal to 2 lots of 2d minus m, 2d plus m. Oop, yeah. Third example. Okay, look at it carefully. What is the first squared number and what is the second squared number? Guys, sorry for all the muck-ups. It's my stylus is at school, so apologise for that. Okay, there's your little squared. Okay, so it's probably not completely obvious to go, wow, where is my A and where is my B? Because I know that I've got 2 numbers there, there's a minus in the middle, but where is my squared? Should I expand this bracket? Well, the answer is no, because actually this bracket is being squared, and so therefore this is my second number, and this second number we can say, well, that's the second number as part of our squared. So if I wanted to write it out as, remember I want it as A squared minus B squared, that means I'm going to be looking at this and I've got, well, A is actually x take 2, and b is actually the square root of 1. So that means that I've got, if I want to factorise it nicely, well, that means I've got x minus 2 is my a, so that goes at the beginning of each bracket, x minus 2, and plus and minus, and then I put in my square root of 1. Okay, so have I got my A minus B and my A plus B? So that's A and that's B, and I've got a plus in the middle, so A plus B. This is A and this is my minus B, so A minus B. And what did we say? When I do those two, it's going to factorise into this form. So if you're unsure and you go, wow, that looks like it might be a bit complicated, just check it. So if I actually did expand it, then I'd have x minus 2 times x minus 2, right? That times that minus that times that is going to cancel out, and I've got this times this, which is minus 1. So, and then there'd obviously still be the bracket. So when they've given it to you in this form, it's not expanded fully. They've only expanded it to a point, because we leave brackets in here and here. Okay, next example. Your gut reaction is probably going to be, okay, I'm going to simplify it because I know there I've got a minus 36 and a minus 12, and if I put it all together it's going to help me, and then I'm going to start to factorise. You don't need to do that in this situation, because what you're really looking for is there a perfect square or a difference of 2 squares in there? Well, if I look at those first 2 terms, x squared, so I've got a square of a number, 36 is the square of what number? Well, 6. So that just means that here, at the beginning, I've got a difference of 2 squares. And at the end, I have another number. So I've got a common factor of those 2. So I'm going to take out the common factor of those 2 and factorise these ones using the difference of 2 squares. And let's see what we get. So let's just separate them first. So I've got x squared minus 36 plus 2x minus 12. X squared minus 36, well, that's the same as x plus 6, x minus 6. And I take out the common factor here, and I've got 2x minus 6. Have I got x minus 6 existing in both? I do. That means I've got a binomial factor. So that means I can move that to the front. And if I move that to the front, I'll have, up the front, I'll have x plus 6, minus 6. Minus 6. and what's left goes in the other bracket. So if I get rid of those and they've gone into the first bracket, what have I got left? I've got x plus 6 plus 2, which is the same as x plus 8. So my answer is x minus 6, x plus 8. Okay, we've got three terms. Three terms, I'm most likely looking for a perfect square if I'm dealing with special products. So that means I'm looking to see, is the square root of this, when I double it and times it by the square root of this, does it give me this answer? So the square root of 16, which is going to be our b value here, so b is 4. The square root of u, which is our a, is just u, right? And I'm looking to factorise it into a plus b all squared or a minus b all squared if I want to use the perfect square rule. Now it's actually going to be a plus because I've got plus here, so I know it must be a plus. And therefore, let's just rewrite this and see if that middle term does equal 2 times the a and the b. So if I work it out, I've got u squared plus, if I make it 2 times, well, b is 4, times u, 2 times 4 is 8, plus, well, 16 is 4 squared, so I've got a squared b squared 2 times a times b, so that means it must be a plus b all squared, right, which means that in this instance, because a is u and b is 4, I've got u plus 4 squared. U squared plus 2 times 4 times u plus 16. Okay, so once again I got three terms, so I'm probably going to be looking for factorising using the perfect square rule. But the first thing I need to do here is look, is there a common factor? There is a common factor. What is it? Well, to go into p, I'm looking for 1 or 3, so, well, I'm looking for something bigger than 1, so let's see if it's 3 that goes through all things. So 60 divided by 3, well, that's 20. 300 divided by 3, that's 100, so, well, it goes in perfectly into all 3. That means I can take it out. So I'm just going to put it out here on the outside of my brackets. Minus 20p plus 100. Okay? Now I'm going to see, well, once again, we're going for exactly what we've just done. Is this term in here in the middle, is that 2 lots of the square root of this times the square root of this? So the square root of p, we'll put our a, which is our a variable. Well, that's just p. The square root of 100 is 10. Is 20 2 times p times 10? Well, yes, it is. So let's rewrite it out nicely like that. So I've got 3p squared minus 2 times 10 times p plus 10 squared, which conforms to the a minus b squared. So that means I'm looking for a minus b all squared, which in this instance, well, a is p minus 10 all squared. Once again, I've missed something, so don't forget that you've got to carry over your highest common factor, which we took out at the beginning, which was 3. Okay, and then you've got exactly the right answer. Also, if you think you're not sure, well, that's not sure if that looks right, let me check it. If you don't have a calculator, then the best method to do that is expand. So you just expand it, put your other bracket there on the other side, so it'll be over here somewhere, expand it out, then times it all by 3 and see if you get this as the result. Okay, so now I think it's time to do some practice. If you're not sure about any of the questions or you're having trouble, make sure you go back and do the easier parts. But if you think you're just going to blitz through it, because this is stuff that was revision, all I want you to do is I just want you to do one question from one part from each question. So if you're doing question 1 and we're doing the purple questions and it says to do column 2, that means that you could potentially do B, E, H and K, but if you're not going to do all of them, then I just want you to do 1K, because that'll mean that you're at least tackling the hardest part from that problem, and then if you've got that, then you would have been able to do all the other ones anyway, and therefore I'm happy for you to be just moving on. Okay, if you're not sure about any of that, just ask me. Good luck. Have a look back over the different questions if you're unsure, and see you in class.